Hi, this is Rob Robles, Product Marketing Manager with the Vision Products Business Unit. The purpose of this video is to take you through the standard demonstration for the new In-Sight 2000 color vision sensors. So first, let's review what it is that you're going to need to be able to deliver this demo. Of course, you'll need a PC with Insight Explorer 5.3 installed, and you'll also need a In-Sight 2000 color vision sensor. Most of you will have a 2000 130C model for demonstration, and in fact one of the demonstrations that I'm going to show you does require the 130C because it includes counting. Next, you'll need poker chips. We have brand new poker chips. That's a multicolored set of red, orange, green, black, and blue poker chips, and you're going to be using, in this standard demonstration, you'll be using the orange and the blue and the red, but you can also incorporate the other colors as well, and I'll show you what I mean by that. Of course, you'll need an Ethernet cable, you'll need your power supply, you need your power cable, power and I/O cable, and then the standard demo tripod and the DataMan tripod adapter plate to mount the camera. And last but not least, you need to have some white paper and ideally also some black paper as a background to use during your demonstration. You must have the white paper for white balancing, and I'll talk about white balancing in a second. But then the color demonstration also works very well on a black background. It makes the colors stand out a little bit better, and it hides any, if you do have some white balancing issues because of ambient lighting in the demo environment, the black paper hides that quite a bit. So these are the pieces that you need to be able to give your color demonstration with the In-Sight 2000 color sensor. And as I said, we do have new demo poker chips. The part number is IS-demo-chip-01. Everyone should be receiving sets of these chips. And you'll notice, in addition to the fact that we now have multicolored sets of poker chips, the colors themselves are very vibrant, and we have changed the label on the front side of the chip, actually on both sides of the chip. We no longer have the yellow background for the Cognex logo. We're going to be using the color on the poker chips themselves for the main part of the color demonstration. I'm going to give you a high-level overview of the standard In-Sight 2000 color demonstration, but first let's review some setup tips for this demo. And the first one is that I recommend a working distance of about 150 millimeters, or roughly 6 inches. This is close enough to the part that the white ring light is providing most of the illumination on the part. We want to minimize the influence of ambient light. Now, if you're in a conference room and there's a lot of daylight flooding in from a window, you might want to get closer so that the ring light is the sole source of illumination on the part. At 150 millimeter working distance, your field of view is going to be about 95 millimeters wide, or 3.75 inches. And again, I don't recommend going with a larger field of view because it's important to keep in mind that color sensor images, they're just not as sharp as grayscale images, and so we compensate typically with a smaller field of view. Now, you may even want to go smaller, but just keep in mind that as part of this demo you want to be able to rotate the chip around, and we're going to have a region that encircles the entire chip, so that's going to limit your flexibility if you make your region too small. So again, these are recommended guidelines. You may need to adjust or adapt based on the demo environment that you're in. Another important point is to mount the 2000 130 color sensor perpendicular to the chip. This minimizes the lens distortion and will improve the performance of the color pixel count tool in this demo. Now, when we introduced the In-Sight 2000 grayscale demo, we suggested that you mount the sensor a little bit of an angle so that to minimize any hot spots reflecting back off the in the field of view off the surface of the chip into the camera. But with these new poker chips, we've got a fairly non-reflective label. You're not going to get local hot spots on that label. You're going to get a nice even uniform appearance, so you can afford to mount the sensor perpendicular to the chip, and in fact you want to do that in this color demonstration because otherwise the distortion will throw off your results, particularly as you move the chip up and into the corners of the image. And then last but not least, you need to assume that you will have to white balance before you actually begin your demo for the customer. Now, you may find you don't need to white balance, but just take a look at the image when you're setting up the light intensity and the exposure. Drop the exposure down, and if the image looks like you're getting some color shift, unwanted color shift in there, you'll need to white balance. Now, there's no need to explain the white balancing to the customer during the demo. This is something you want to do before you really begin the heart of the demo. It's just not important at this stage of the selling cycle to take the customer through the whys and hows of white balancing. So after you've white balanced and you're ready to begin the demonstration, the very first thing you'll want to do, of course, is to locate the Cognex logo with the pattern tool. This is the fixture that we're going to be using for the color pixel count tools and a couple other tools that we'll add. The logo training guidelines are different than what you were trained on earlier this year when we introduced the monochrome In-Sight 2000 sensors. Specifically, you'll want to train the logo with just a little bit higher than the Cognex logo, and then down below the black bar, the Win with Cognex black bar. And this will make sure that as you're rotating the chip, that we're not finding the logo in the wrong orientation, which would throw off other tools that are fixtured to the logo. Next, we're going to count the pixels on the outer edge of the poker chip, and you should be using the orange poker chip, and I'll explain why that's going to be important here in a bit. So you'll count the pixels on the edge of the orange poker chip, and you do that with the color pixel count tool, and I'll show you that in just a moment. Next, you'll add blue to the color pixel count tool. So with one tool, we're going to find both orange and blue poker chips, and then after that, we'll show how we correctly fail on the red poker chip. Now you may be wondering, well, why is that so important? I'll explain in a moment. And then finally, optionally, you can, with the color sensor, a good demo would be to find other defects on the backside of the poker chip. So incorporate some of the elements from the standard grayscale demonstration. Specifically, you can count the chip stacks using the counting patterns tool. You can also train on the horseshoe, and then when you flip it over, you're going to fail correctly. You'll fail because we have dice on the back instead of the horseshoe, and likewise there's only one chip stack instead of the two. So you can show other elements, how this isn't just a color pixel counter. You can also inspect other elements using the standard In-Sight 2000 color vision sensor. Okay, now we're ready to do the actual demonstration, which is the main part of this video. But before I do the demonstration, I need to set up my image. So of course, you're going to adjust light intensity and exposure, but it's a color sensor, so I also need to be concerned about the white balancing. Now, in order to white balance, you need to have a white sheet of paper in the field of view without any object, without any poker chip, and it cannot be saturated. Now, rather than adjust the light intensity, because that'll introduce some changes in the color tint in the image, I'm going to adjust the light exposure to get this image so it's not completely saturated. And then I take it offline, or take it out of live mode rather, and over on the right here you have the white balance controls. First of all, you need to verify your white balance region. Now if it's a brand new job file, your white balance region is going to be the entire field of view, which is what I suggest for this demonstration. So I'll go ahead and leave that and click OK, and then just click the Set White Balance button. And it changed the color a little bit, made it a little cooler, not quite as, or a little warmer, not quite as greenish blue as before. Now I want to put my poker chip back into the field of view. And actually, I'm going to demonstrate on black paper. I like the black paper as a background for the color sensor because it makes the colors pop a little bit more. You don't get as many shadows and things off the white that could throw off the color pixel count tool. And if there are some color tints in the corners of the image, they're not as apparent here with the color with the black background. So I suggest using the black background. You can give the demo with white. Just be aware that you might see some color shifts off in the corner even after white balancing. And this is actually just something that comes along with the white ring light. As you increase the intensity of the light, it shifts the color of the image. So the black paper will sort of mask that. Now I'm going to go ahead and increase my exposure a little bit because I'd like to get this image a little brighter, and maybe even a little bit brighter still. Okay, so now I've got my orange poker chip in the field of view. I'm ready to begin the demonstration with the customer. The first thing I need to do is to locate the chip, and we'll do that with the pattern tool. So I go to locate part, location tools, select pattern, and as I said before, you'll want to train the pattern around the Cognex logo. I'm going to rotate this just a little bit in the image so it's aligned better. The Cognex logo that you want to have the upper boundary of the model region just above the Cognex logo, and you want to have the left and right just extending past the logo, and then the bottom edge of the model extending past the black bar on the bottom with the Win with Cognex text. And this will give the trained model enough mass at the bottom so that you won't find it at 180 degrees opposite of what it really is, which would throw off the rest of the inspection. So go ahead and click OK here. I'm going to name the tool. This is always good practice, particularly in a demonstration, so that as the customer is looking at the results, they can easily relate what they see in the results tab here to what they see in the image. So I'm calling this logo, and I will be rotating this chip during the demo, so I'll go ahead and increase the rotation tolerance to 180. And now I'm ready to actually do the first color tool here. So the color pixel count tool is what we have on the color model. On the grayscale model, it's just pixel count, but here it's color pixel count, and I'm going to add that. I'm going to add it in a annulus region, so that's down here. The annulus region is the gives us that ring that we want, and because I've got my field of view set to roughly 95 millimeters, 3.75 inches wide, that's already optimized for the annulus tool, so I don't even have to resize it. I just have to position it around the center of my chip and just make sure that the color of the chip is enclosed within the inner and the outer boundary. So I'll go ahead and click OK. Now when you add a color pixel count tool, it will always fail in the beginning because you haven't trained any colors. Let's first go ahead and name this tool. I'll call it chip color. And now I have to train some colors for the tool in order for it to pass. So I click on the train color button. I get to the eyedropper here, and I'm going to select colors on the chip. As you move around the chip, you'll see the color that you're currently going to train if you were to click in the color to select area there. So I'll click a representative color, and it did okay, but I'd like to get a little bit more, so I'll go ahead and click, actually I'm going to increase my tolerance here. Now I'm going to increase the tolerance to about 4, and I don't recommend going too much above that. If you do, you'll start to pick up some shades, even some shadow that aren't actually part of the chip that you don't want, or you'll have some confusion with the red chip, which I'll show you later. Don't be afraid to add a second color tool. In fact, that's how the tool works. For robust demonstration, you will almost certainly need to select 2, maybe even 3 shades of each color. And this is because as you move the chip into the corners of the image, the image uniformity is not the same out in the corners as it is in the center, and you'll get some color shift. And so you want to make sure that you're getting the most robust selection possible. So I've got 2 different shades of orange here. I've increased my tolerance for both. Now before I click finish here, I want to point out there's a control that we have here called ignore brightness, and what this does, it's enabled by default in a new job. What this does is count pixels that are a little bit darker and a little bit brighter, so the intensity of those pixels is darker and brighter. It includes those, so it's the tool, the color pixel count tool, in its most inclusive, permissive state. I'll show you what happens if I turn that checkbox off. I lose some pixels. Sometimes it's a lot worse. It just depends on the image and what values you're using. But I'm going to go ahead and leave it on here. You'll get the best results in a demonstration if you leave that on. Alright, now let's go ahead and finish the color selection. And you see that my color pixel count meter and pass range has automatically been set to what it thinks is the optimal range. You can see the colors that you trained here. I've got 2 shades of orange here. And let's see how this performs. So I'm just going to move the paper so my hand is not in the way. And as I move the chip around into different areas of the image, you see you'll get some variations in the pixel count, but it's still within the range. Now, I am losing a little bit over here, which I don't like. So don't be afraid to go ahead and just add another color. You can do that while you're in this repeating trigger mode. It's actually a feature of the tool. I'm going to go ahead and add this some of the color that it's missing, and now you see we're getting a darker orange. I click Finish Color Selection, and we're getting a much better result. And by the way, this isn't something to be fearful of. It's the way the tool works. It's a feature of our tool. The fact that we show you the colors in the tool itself, we show you what you've trained. And if you're comparing to our competitor, say Keyence, they would have to click many times to collect all the colors, and you'll see some demonstrations of that, not in this video but in other videos and materials that we're preparing for you. You'll see demonstrations of the Keyence and how it works, and ours works better. Alright, so I've got the chip there. I'll go ahead and flip it over. You see we're still finding it, obviously, and we're still counting the orange pixels of the chip. Now as I move the chip such that the annular region goes outside the image, it will fail. No worries, just move it back so that it's comfortably within the image, and everything will pass. Now if I throw another color here, if I say the blue chip, you see we're not really finding any orange pixels there. We're still finding the chip, but this is correctly failing at this point. Now let's do a little bit of a tougher test. Here's the red chip. And as we move that into the image, you'll see we're not really finding anything. We're not confused by the red at all. Okay. And likewise, I could also throw green under there, and we're correctly differentiating the green from the orange. Put the orange chip back in, and now we're back to passing. But let's give it a little bit of a tougher test. So let's go ahead, and I'm going to train in the same tool. I'm going to go ahead and add blue. So it's a completely different color than orange. So in this, basically we're simulating an application where I don't really care if the part is orange or blue. It can be either, and or even both, and I want to pass. You could do that by creating a separate tool, but we don't have to do that. We can go ahead and add another color, and so I'm going to go ahead and go back to training colors, and I'm going to add blue. And when I click on the blue, you see I get a lot of that. Let's go ahead and I'm going to go ahead and increase the tolerance of the blue to get more of it. I still want to get a little bit more of the darker shade, so I'll click that. There we go. Make that a little more robust. And now when I click the Finish Color Selection, you can see I'm looking for orange, I'm looking for blue. If I put the orange chip back in, we still pass. I can put the blue chip in, and we still pass. Now here's what's interesting about this. If I put the red chip in, of course we expect it's going to fail, and it does fail. And what you're going to find, what's very fascinating, is if you did this exact same operation, this exact same demo with the Keyence IV H color sensor, they would fail here. They would actually count the red, and I'll show you how that works in another video. But that's the point of this part of the demonstration, is we want to lay a trap. If we have our orange, and we're finding that just fine, we have our blue, we're succeeding there, and then we have the red. Of course we want to correctly fail because that's neither orange nor blue. Likewise, we're going to fail on the green. It's not orange, it's not blue. And obviously we're going to fail on the black. All right, we get a few pixels, but nothing that is going to throw us off. All right, so now I'm going to get this back into the center of the field of view here. And that's the basic demonstration for color. I always recommend that you go to the Run Job step because you can see these nice bright green pass graphics or red failure graphics, and that really, I think, emphasizes to the person you're demonstrating for. They can see everything very clearly, and then when we throw in the wrong chip, it also indicates that it failed because the chip color is the wrong chip. So that's always a good thing to do. Name your tools and go to the run step to complete the demo. But we can go farther than this. This is an In-Sight 2000 sensor, and even though we're looking at the color, it's a color imager, we can do other inspections, of course. It's not just limited to color. And so you can go farther than this, and by adding a couple other tools, and we'll just borrow from the what we did with the standard In-Sight 2000 grayscale demo. For example, we have a horseshoe on the front and a picture of some die on the back. I want to fail if it's a die, I want to pass if it's the horseshoe. I'll go ahead and add another tool here, a pattern tool. Actually, I'm sorry, I want to do the inspect part pattern tool here. We'll get that trained. And of course, since this is fixtured to the logo, I don't need a very large region, and I'm not going to need any angle tolerance. So I'll go ahead and set this to I'll set this to plus minus 5 degrees, and I'm going to call this horseshoe. Now I also want to count these chip stacks. There's 2 on the front, 1 on the back. I want to fail if we only find 1 chip stack. So in that case, with the 2000 130 and 130C model, we have the ability to count patterns, and beginning with In-Sight 5.3, we can return the numeric result. That's what I'm going to show here. So I'm going to position I'm going to train my model around one of the chip stacks and position my search region around both of them. And I'm going to call this tool chip stacks. Go to the range limits tab. It says we're finding 2. My min and my max is 2. That's exactly what I want. And now let's go to the run job step here. Put it in repeating trigger. You see we're passing all of our inspections. We have the orange chip. We're failing the chip stack counting inspection back here on the back side because we only have 1 chip stack, and we're failing the horseshoe inspection because we can't find the horseshoe. We're seeing die. If I move to the blue chip, still passes because I said blue or orange is fine. All our inspections are passing. I move to the back, and our chip stack and our die are failing as expected because they're not what we want. And now I could go back to my red poker chip, and now we're failing. Of course, we're finding the chip stacks and we're finding the horseshoe. We're still failing the color inspection because it's neither orange nor blue. I flip it over, and we're failing all the inspections. We're finding the logo, but that's about it. Other than that, we're failing all the inspections. So you can show the customer more than just color with the color sensor. I recommend staying with patterns and counting when you're doing this demonstration. You can obviously do measurement with the 130C, the 2130C, but if your purpose is just to show measurement, I strongly recommend doing that with the grayscale camera. That's really still our lead demonstrator, is the grayscale 2000. Color, you really only need to show it if the customer has a color application. So that is the overview of the demonstration. Hopefully you will be able to recreate this on your own in your office practice. And you should be able to give this demonstration very reliably, and while at the same time laying a little trap for key-ins. So thank you very much. I hope this was helpful.